Okay, so it is a pleasure to introduce you to Mr. Adrián Pino-Martínez. He is currently a researcher and R&D cloud engineer at EETAC.
Yes,
right?
Exactly.
Because yeah. And you have been involved in this 6G Sunrise project, right?
Exactly.
We're very happy because Adrián is actually an alumni of the school. He has been, he was a graduate from MASTEAM, so it's always very nice to have all the students here. Okay, so thank you very much. The floor is yours.
Yeah, thank you very much. First of all, thanks for the invitation. It's a pleasure. It's really nice to come here because, as David said, I was sitting there like 4 years ago. And actually, my boss came here and gave a presentation of 5G, cybersecurity, and this stuff. And after the presentation, I talked with him, like, I like your topic. And then in the end, yes, I've been with them like for the last 4 or 5 years. So this presentation is about 6G, but don't be scared. I will quickly introduce what is 6G and what is the interesting thing that we are tackling on this project. And as the name says, shaping the future of 6G through federated systems. So the talk would be about how federation work in order to use some operator resources and some other operator resources. That could be on the same country or on different ones. First of all, I'm going to introduce you very quickly EETAC. EETAC is our research center located here in Barcelona. Actually, it's nearby Campus Nord building there in Barcelona.
Nexus.
Yes, Nexus building. So basically, it's an R&D research center. So we do research. We do from fundamental research to more applied research. And also we have some innovation projects with the Generalitat or private companies from Spain and outside. These are the research and innovation areas. So we have smart networks, artificial intelligence, space communications, digital society technologies, cybersecurity and blockchain, and also immersive and interactive technologies. And in the middle, you could see the different verticals that can be applied. So telecommunications, autonomous and connected mobility. We do have a team on smart vehicles, sustainability, and so on. Some quick numbers: we are 250. 20% of the people is PhD, and maybe I would say another 20% is pursuing another the PhD. 30% of women, and we're growing a lot. So we have 3 times more. And when I joined the company in 2019. So guys, we have a lot of open position in different fields. So check EETAC.
And you are not the only one coming from MASTEAM, right?
Not at all. Actually,
Timo Kellerman?
I was thinking, and from the top of my head, I can count 10 coming from MASTEAM, Math, or Med. So we have a nice connection of the content of these masters and the work that we do there. Okay, so I'm gonna talk now about 6G, about the topic. As I said, it's related with federated systems. But first of all, what is 6G? Because you are currently, I bet you're learning what is 5G, and now I'm bombarding you with this new topic. So 6G is under research, of course. So 6G is the 6th generation, and basically, it will be shipped around 2030. That's the estimation, and well, as you can imagine, from 4G, 5 to 5G, and to 5G to 6G, we improve things such as speed, of course, latency, of course, and AI-driven intelligent networking. So AI is capital in 6G. It's being really used in 5G, but in 6G will be part of the architecture. So we are currently shaping the architecture, taking into account all the intelligence that AI will provide. In order, for instance, We have a QoS in a given time. With AI, we detect that we will have way more traffic because this or that. Then we are able to react in an elastic way. 6G will integrate all the features, terahertz frequencies, satellite connectivity. In Barcelona, actually, a very nice company working with 5G and satellites. Real-time holographic communication. Actually, we have a team dedicated to the holographic communication. So they have, for instance, a use case where they place different cameras. So you have like a 3D capture of your image, and another person with this smart headset can watch it in real life. So with these cameras and the headset, the radio heads, you can produce like a 3D image and talk with that person. Also, of course, autonomous systems, smart vehicles, all these verticals will have a lot of interest in 6G. Then I'm going to talk about federation, but I would like to introduce you first the problem. So telco interoperability is a problem, and this is a fact, and we saw that from 4G to 5G, and some concepts such as virtualization came, because in the past, I'm configuring my radio device, my router, which is Nokia. Then what happens if I would like to use a new one? I need to buy the new devices, and this wasn't scalable at all. So virtualization came and solved this thing. Then we have also interoperability, even from the operators. So when we talk about interoperability, what solution comes directly? Standardization, of course. So then I'm going to talk about this standardization body, which is CAMARA. So 2 years ago in Mobile World Congress, Telefónica, Deutsche Telekom, and the big players sit down and they hit the breaking news. So they allied. This has been shocking because these private companies, private operators, that they are rivals, they allied, and they said, okay, we are gonna work on a common API, so that no matter if I'm using like Ericsson Core or Telefonica Orchestrator, Deutsche Telekom Smart Mobility System, we don't care. We're gonna build a common layer on the top among everyone, and from that, users can consume our resources. So no matter a user can consume Telefonica resources, can consume Deutsche Telekom, no matter, because the API would be the same. And then GSMA came here in 2021, so this is a bit old, but now it's getting a lot of attention, and they said, okay, because you are talking on someone consuming you. So you are facilitating how one can consume, but what happens if I'm an operator and you're another one, and I would like to use your resources for a given time? Of course, we need to pay, and this billing is key. But then they created the operator platform group, which is a group that is building on the specifications and specify how operators could be integrated. So they define this architecture. I won't get into detail, but they define this east-west bound interface, which is key. So they define a standard way where this operator, Telefonica, and this operator, Deutsche Telekom, can communicate. Again, APIs. APIs are key in 6G and are key also in 5G currently.
So can you questions a lot in between?
Yeah.
Trying to understand, you give the example of Telefonica and Deutsche Telekom.
Yeah.
Probably Telefonica, when you say that it's not Telefonica Deutschland, it's Telefonica here.
Yes,
Spain. Spain. So they are in different countries. So are you speaking about their interoperability like in the core level? Or are you speaking like you have Movistar here, and or you have also, let's say, Orange? So would it be what you are telling is also relevant with the ones in the same territory, in the same?
Yes, yeah. I mean, this concept could be applied in the same territory in different countries. It's not stick to anything. So it's open.
Because they can now use by national roaming. if there is no coverage from the other one. What we speak is like changing the business model in total.
Exactly.
So you are changing the business model. What you are saying?
Yeah, the thing is that one thing is roaming is for communication that you have or you are connected, but what happens with compute resources? What happens if I'm a company, a video reality company, and I would like to place my huge app with a lot of bandwidth, 50 critical CPUs here, and then I have some customers which are nearby you, and I would say, okay, let me some resources, I will pay you, but this customer needs to get the quality of service that they are paying.
So something similar to run sharing in this case.
Run sharing, compute sharing.
Compute sharing, yes. Okay.
So via this standardization of the east-west bound communication, this becomes a reality.
In the same territory as well, not between
Exactly.
the countries. Okay.
Exactly. So again, this is also a decision, a strategic decision of the different operators. The technology can be ready, but they could decide that that's it. But one thing that is key here is that what happened with universities, what happened with research centers around Europe, for instance. So let's say that we have a testbed, an operator in University of Oulu in Finland, and these guys have a lot of money and they have a lot of knowledge in radio. So they could have a really fancy devices there. And then someone from Universidad de Málaga, for instance, they are very good in compute, in cybersecurity, and they would like to test those devices and place their app there. So thanks of this paradigm, you can also federate the different tests and universities. Okay, so we're working on this, and of course we don't work for free. So there is a European project funding this research, and this is called Sunrise 60 projects. And the goal of this project is to federate all these different dots, different research centers, universities from Europe. So again, this is the project from this point of view. So we have different testbeds. We have EETAC testbed, Oulu testbed, which are good, very good in 6G. Again, and the objective of the project is to build this common layer and to demonstrate that, okay, this works via this east-west bound communication that I said. And also Camara, again, will be used in the north. And yeah, basically this is what we are producing. So no matter which radio technology, which transport technology, which core are we using, via this system, we could use the resources from different operators. So this is very interesting because, for instance, this operator is using Ericsson core and the other operator is using Juniper core, and you could still be using those resources for a given time. So I'm paying you, I'm using that resource. I don't know how to configure, but I'm still able to use it. And this is like the output of the project. We are talking with ETSI, the European Telecommunications Standard Institute, because the goal is to make it open source. I mean, we're doing research with public money. That's the goal, that everyone is able to use it. So we have proposed them this architecture and these modules, and ideally this will be free to everyone and open very, very time soon. And yeah, that's all. I'm happy to answer you any kind of question. As I said, we have open positions in EETAC. It's a good place to develop your career. And yeah.
I can remind you that you can do internships during the master, okay? And there can be also possibilities for the master thesis, because many people.
Actually, I did my master thesis with them via an internship, and I aligned my master thesis topic and the internship and was exactly doing it. And after that, then I got offered the contract. So
okay, so regarding this abstraction layer, that if I understand correctly, is the Camara app.
Yeah, Camara is for the north, and this is GSMA, the one.
So what has been exactly the development during the project?
Yeah.
The interfaces, or is it just a proof of concept that the API works correctly with different equipment? What has been exactly the contribution of the project?
Exactly. So we start from the point that this camera is an API, standardized, and that GSMA is another API. But an API is not an actual implementation. It's just how you are going to consume this. You need to follow these rules, but then how you do it, how good or bad you do it, is up to you. So in the project, we have developed all these modules that were defined by the standard. And for instance, EETAC has led the Federation Manager. So we are able to, when we receive a call that says, I need resources from here, we have to implement all the communication, which of course needs to be secure. No, this is mandatory. And then how this element is communicating with the underlying infrastructure. So that's what we have doing.
You call them open operators.
Yes.
So is it something different than the commercial operators at the moment? Or?
I mean, we define it like this because the goal is to be open source, and then different universities, as I said, research centers could be used. Also could be commercial ones. So we are proving that this makes sense and it's really easy to use other ones, resources, radio resources, compute and transport. And then, yeah, it's up to the operators to take the solution out.
It's interesting because, when we speak about these Gs, they are by regulators, this frequencies for these Gs are 5G, 2G, 4G, whatever, granted to the operators, licensed. So they are not that open. They are licensed, and not anyone can use it. So if you want to use it, you need to have a license, or you need to rent something from who owns the license, like Movistar or Orange. So how I thought 6G would be something in a similar concept, like the government or the regulators would be licensing it to the operators. So how can it be open?
Yeah, I mean, that's a reality. In the end, you pay for the frequencies that you are using, but federation means that I'm sharing with you resources, but maybe I would like only to share my 10% of my compute capacity, or maybe I would like only to share with you a small frequency band. It's up to you. You're not sharing completely everything because maybe you are impacting badly on the other operator.
So it's still an operator
that
has the license.
The business in that sense will be still the same, but now we have the capacity to say, lend me some radio or some compute because I need to serve a customer for a given moment. That's all.
And I think for 5G, there's still something missing that's called intent-based mechanisms to make network like resource allocation and other things, to have an intent-based management. And I think it's expected by 6G. Yeah. So is there anything these federation is helping that intent-based management?
Yeah, I mean, the goal right now is to validate the sharing of resources, but this intent concept is something that you could add on top of it. And the intent thing is that I would like to do things, but explain it in a very easy knowledge. So,
as well.
Exactly. Instead of saying, I need this frequency with this quality of service, with all this complexity, the intent, networking and intent, programmability, all this intent concept is like, I have a user for a video streaming. And then this is translated on different specifications. But again, this is an upper layer that you add because you still have APIs to do all what you want. To instantiate apps, to change the quality of service, to detect where is the closest edge to that device.
For that purpose.
So yeah, that's definitely considered in 6G. I mean, 6G is right now in the beginning. There are many projects which are exploring. This one is focused on federation, but yeah, that's one hot topic, I would say.
The last question, any provision about time to market of 6G, when 6G could be commercial, probably in 5-10 years? Because 5G has been already there for more than 10 years now.
Yeah, already there.
Yeah.
Depends,
somehow there.
Depends. In China, is full 5G. The States depends here in Europe is scarce. Yeah, it depends. It depends.
Normally the cycle was about 10 years between each generation. Now it's taking a little bit more for 6 years, as far as I can see.
Yeah, the thing is that it was like an over promise of 5G. Like everyone said that 5G is gonna save the world, is gonna beat all the KPIs, and the reality is that okay, reality is a bit.
They are still using 4G in several places.
Exactly.
Specifically for the ultra reliable and
Yeah.
low latency services, which are really, really hard.
Yeah.
Operations, medical operations, and kind of.
Yeah, this kind of.
Exactly. That's an interesting conversation about, yeah, for instance, for 6G, what they are saying is that instead of like 5G that we define a non-standalone and standalone, so you have both. No, we will only define the standalone, so then people will focus on the new one. Otherwise, you don't pay that much attention, investment.
So yeah, with 5G they try to bring that standalone thing, but it never works. Although there are standalone, non-standalone is residing the standalone in many operators.
Yeah.
So with shift it can change because there's a big investment behind. You cannot just throw away that big investment and go there.
Yeah.
For example, I'm from Turkey. Turkey is just starting 5G next year. Still not that, and it was mainly because of the investment cycles. The government didn't want to invest because we don't produce 5G. So it looks like 6G is a little bit longer to come.
I would say so. My shot is that they are a bit more conservative in that sense because they have learned the lesson from 5G. Again, this depends. Geopolitics affects a lot the materials, but yeah, I would say.
For the companies that operate in the telecommunications world, it is good that new technology comes because it is some business for every company. So that's always a point of interest when the next one will be coming.
Yeah, and actually with 5G, you saw it from 2G to 3G, from 3G to 4G, and then from 4 to 5, a lot of verticals have opened. Drone companies with 5G, surveillance of factories or whatever. So, yeah.
Good luck.
Yeah.
We have a question from the online audience. Mark?
Hi, everyone. Thanks, David. Hi, Adrián. Interesting project. I saw the web page of the project. And could you explain a little bit about the use cases? I've seen 3 use cases, if I'm not mistaken, or at least the one that you will work on, and which are the requirements or benefits of using this API.
Okay, yeah. Thanks for the question. But yeah, these research projects always they have some use cases in the end to prove that whatever you're building makes sense and helps the society. But we are leading one use case that is about holographic conversation, and we call it federated holographic conversation. And why this federated? Because again, this thing of holograms, you need the headset, so you put your glasses, and then you're seeing in 3D a person. If you turn here there, you still could see like the entire shape. Why? Because that person is being recorded with many cameras. The information is compressed using some volumetry protocols. Okay, so still bandwidth is a KPI, and of course latency is a KPI, because if I'm talking with you in a real conversation and you have a lot of latency, you don't have this human interaction. But then with this federation, we can detect that from where you are sending your image, you have a server close to you in the edge. So then we said, okay, that part will be processed instead of under my facilities, which are in Madrid, maybe in Barcelona, because you are closer, you process there the data, and then this communication is better in terms of latency. So again, this is a proof of how federation can help us in this case.
Okay. So I asked resources in the Barcelona site, and they are given to me based on some criteria, and then this holographic video runs much better, right? That's the idea. So
Exactly. That's the point.
so okay, thanks. Yeah. So this holographic video would be much better, because online meetings or presentations, I mean, it's a mess. You lose the communications between you and me. Even if I put the video, it's not the same. Yeah.
Exactly.
Congrats. Thanks.
Yeah. Well,
By the way, I plan to invite Sergi or Mario to give also a talk about this.
Exactly.
Really nice.
Exactly, because the cool thing is that we have a dedicated team for that in EETAC, and they have been speaking for the last 10 years about holographic, and now they have built a product and opened a company, a spin-off. So it's very cool that from research you could see that in the end you can make it into the market. That's
What was the name? Because it was announced on the news like 2 weeks ago or 1 week ago, right?
yeah.
This company, this startup.
I don't recall. I know that the software is called HoloMeet, from holographic, HoloMeet, but I don't recall the name of the company. But yeah, in Mobile World Congress they will have a booth and present to the users. But yeah, it's quite nice. It's a nice team.
Okay, so any other question from the audience here? Or from the online audience? No? Okay, so thank you very much, Adrián.
Yeah,
It's a
thanks.
pleasure.
Thanks for it.
Thank you, David and Adrián. Bye bye.
Thank you.